Welcome to Legacy IAS. So we are here for your revision and practice class. Our main focus is number system. Okay. Now, number system, first we'll be using the slides that we used in our class. In class, what we used, same slides we'll be using for revising the stuff, and then we'll be doing questions according to after each topic, after each subtopic of number system. Let's get started. So first was this number of questions. Okay, in this year also, the way CDS paper and the other papers look, it seems that there will be substantial number, 20 plus questions of number system only. Okay, so be ready for it. Then first thing we saw this, correct? What was this? Real number. Then this was rational, irrational, integer, whole number, natural number. All that is fine. Now we also know about two, three more numbers. You know about even numbers, odd numbers. Even number was what? Which were divisible by 2. Is 0 an even number? Yes, 0 is also an even number because 0 by 2, you're getting a whole number, correct? Then, now we come to divisibility. Divisibility rule, you must remember last digit multiple of 2, then 4 last digit multiple of 4, last 2 digits multiple of 4, 8 was last 3 digits multiple of 8. Now, can you see a pattern? We talked about this, that here you are looking at only one digit, then two digit, then three digit. If it is 2 power 4, that is 16, how many digits will you look at? You will look at the last 4 digit. If it is 32, 2 power 5, you look at last 5 digits. This I always teach. This time they asked also. Okay, we'll see that question. Then 3, 9, what you have to do? Create and cancel multiples of 3. I think you remember this. Then if everything gets cancelled, then it is not divisible by 3 or 9, otherwise it is. Then 5 and 10, last digit has to be 0 or 5, last digit has to be 0. Remainder also for 5 and 10, it's very easy. The last digit itself became the remainder for 10. For 5, what becomes the remainder? So if it is 1 to 4, then those are the remainders. If it is 6 to 8, then again it is 1 to 4 as the remainders. So basically that is how you find remainders also for them. Then 7, 11, 13, these are the series 1 minus 2 minus 3 minus 1 2 3, correct? 1 minus 1 1 minus 1, this you must remember. 1 4 3, 1 minus 1 minus 4 minus 3. Okay, this is for 30. All these you remember. Then set 5 was for composite numbers. What you had to do? You had to choose pair of co-prime numbers. Remember co-prime, which may be prime, may not be prime, both composite, does not matter. For example, 8 and 9, they are co-prime numbers because they have nothing common between them, correct? In fact, if you see any consecutive integers, for example 8 9 or 9 10 10 11, of course they will be co-prime in nature because the difference between them is one only, correct? Then so how you find this? So for 6, divisibility rule of 2 and 3, for 12 3 and 4, for 18 2 and 9, because these are co-prime. Similarly for 24, this also you remember. Now it's time for this blank sheet, means it's time for questions. Let's get here. Yeah, so this is the first question. This was asked in CSAT 2025. So 1 2 questions that I think that I didn't take during the crash course, that I have taken. Otherwise most questions are from CAPF and other CDS of different years. Now let's see this, fairly easy. What it says, consider the first 100 natural numbers. How many of them are not divisible by any of 2 3 5 7 and 9? Now what do you think? See, first thing, it is asking you about the natural numbers till 100 which are not divisible by any of these numbers. Now understand one thing. One thing I have taught you already, that if it is asked, for example, if it is asked 101 is an prime number or not, so what you do, you take its under root and you only check for those numbers which are less than its under root, correct? So here if you are checking till 100, then the under root of 100 is 10. So if I check for all prime numbers below 10, then I'm done, correct? So then that ensures that it is a prime number definitely. So if you have to check, if you get confused, otherwise one thing you should remember, that between in first 100 natural numbers, there are 24 prime numbers. There are 24 prime numbers. Now, one more thing is there that we'll see. So now you see 24 prime numbers are there, and there is one more very special number called 1, which is neither prime nor composite. This you remember, correct? Now let's see. So how many numbers are there which are not divisible by any of them? See, 9 does not matter. Anyway, it's a composite number. If something has to be divisible by 9, must be divisible by 3 only. So checking by 3 only can reject that case. So how many prime numbers do we have? We have in total 24 prime numbers, and one is also not divisible by any of them. So 24 prime numbers, let's take this minus 2. 2 is also a prime number less than 100, but it is divisible by 2. Similarly 3, similarly 5, similarly 7. So I must subtract these 4. So now I have 20 other prime numbers which are of course not divisible by any of these, correct? But I also have one more number that is not divisible by any of them. That is the number 1 itself, which is neither prime nor composite. So 20 plus 1, what becomes the answer? 21. 21 becomes the answer. So how many such numbers? 20. Fine. Please remember this, that there are 24 numbers like this, and there is one also. 10. Let's do next. Let p is equals to n square, where n is an odd integer, the remainder when p is divided by 8. Now, you need not go in detail of questions like these, which involves a random variable, then it is asking you about something. You only need to think in terms of examples, nothing much. Now, let's start thinking in terms of example. Just check for 3-4 numbers. If you're getting the same result each time, mark it. Okay, mark it if you're getting it for 3-4 different numbers. For example, here n is an odd integer, so I take n is equals to 1. What it becomes? P becomes 1. If I take n is equals to 3 odd integer, then p becomes 9. Otherwise, if I take 5 square is 25. Correct. Then next would be 7 square is 49. What I am getting if I am dividing them by 8? Remainder 1, remainder 1, remainder 1, remainder 1. 1 is the answer. I am not even going in detail of how this comes about. Not important for us. Only check for 3-4 numbers like this. If you're getting the same result, you just mark it correct. Why? When there are general terms like this, p is equals to n square, n is any odd integer. If it is any odd integer, then let's check for 3-4 of them. That's it. Next. Now, this is divisible by how many natural numbers less than 10? How many natural numbers less than 10? Now, how do you check this? See, first let's make this more palatable. How you will make this more palatable? So 27 power 27 minus 9 power 40 minus 3 power 79. Let's write all of them in terms of 3 power. So this becomes what? This is 3 cube, correct? 3 cube. Now 3 into 27 is 81. So this becomes 3 power 81 minus. This is 3 square. 3 square into 40, that is 80. Correct? 2 into 40, that is 80. Then minus 3 power 79. Now what can you do? Now I think you can feel it. 3 power 79 you can take common. What remains here? 3 square, that is 9 minus. This is what? 3 power 80. This is 3. Correct? Only 1 is remaining. Correct? Now here nothing is remaining. So 1 I have put. So 9 minus 3 is 6. 6 minus 1 is 5. So this actually becomes 3 power 79 into 5. Correct? How many numbers divide it? Divide this expression. So now one number you should not forget. See, again they have tested this. Okay, that you should not forget 1. Is 1 dividing this? Of course it is. So 1 is one such number. Then 2, of course not. 3 and 5 only are there. So not 2, then 3. Yes, 3 is dividing it. Then not 4, of course, but 5 is dividing it. then 6 not possible, 7, 8 not possible, 9 is possible. Why? Because you have 3 square here. So how many numbers? 1, 2, 3, 4. More than 3 becomes the answer. If you would have forgotten one, you would mark 3. So always be careful of, for example, if they talk about divisibility, always think about 1 also. If they are talking about even numbers, always think about 0 also. If they are talking about prime numbers, always think about 2 also. Okay, so these are some things that you must check. Then, what is the sum of all divisors of 256? What is the sum? Now, there are formulas also by which you can get this. I can tell you the formula if you want. See how it works. For example, if n is equals to p power a into q power b. Okay, let's take a more realistic example. 36. 36 is equals to 2 power 2 square into 3 square. Correct? 9 4s are 36. Yes. Now, if you have to calculate the sum of all divisors, sum of all divisors or sum of all factors, what you have to essentially do, here it is 2 power 2. So what you have to write? You have to write till 2 power 2. So 1 plus 2 power 1 plus, yeah. So 1 plus 2 power 1 plus 2 power 2 into 1 plus 3 power 1 plus 3 power 2. This is what you do. 2 square is 4. 4 plus 2 is 4 plus 2 is 6. 6 plus 1 is 7 into. Now 3 square is 9. 9 plus 3 is 12. 12 plus 1 is 13. 7 into 13, 91 becomes the answer. This is how you calculate sum of all factors. Sum of all factors or divisors if you are taking it here. Understood? This is the formula. Now, if I apply same thing here, I can get this answer also. But let me tell you, first let me do this by the formula and then we'll see. So 256 is what? 256 is very simply 2 power 8. Correct? This you must know. Correct? 2 power 6 is 64. 64 into 4. So 2 power 8. Now, what you will do? You will start adding 1 plus 2 plus 2 square plus 2 cube till 2 power 8. Now, if you start adding them, 2 power 8 is what? 2 power 8 is 256 itself. Now, if I have to add other numbers, if I keep adding other numbers, now see how I do it much faster using the options. First thing you see is 2 power 8 will be added, correct? Even if you didn't know the formula, you know that 256, one divisor is 256 itself, correct? So it must be greater than 256. Now you are chasing these two options, 510 and 511. Now see this. See how I use the odd even concept. Even. All of them will be even. So some will be even, but one is what? One is odd. So this becomes odd plus even. Odd plus even is odd. So the answer has to be odd. Answer is 511. Understood? So if I wanted to do like the first time I saw this question, I saw it like this only, that it will be like 1 is one of the factors and other factors are all even. So even plus 1, eventually I will get odd. So you can reject 256 and 510 like this. Now 255 is not possible because 256 itself is one of the divisors. So 511 becomes the answer. Any way you like, you can get to the answer. Then now, before this, now we need to get back to the revision part. Let's go. Yeah. Now we came to special numbers. Correct? Remember them? Now, triple one was 3 into 37, 1001 was 711, 7 into 11 into 13. Then triple one was all this being multiplied. So it was triple one into 1001. This gave 3 into 7 into 11 into 13 into 37 like this. Okay, now similarly 1 2 3 1 2 3, how you used to get triple one into triple one into 1001 used to give you 123 123. So you got this. From this you got all the factors. I hope, because we have used this so many times, that you at least remember this. Okay, XYZ, triple A double zero A, and triple A. What are the factors here? Okay, now one more thing was this. This also we had seen. Triple one into triple one is 1 2 3 2 1. So how many ones are here? Till that point you have to go. For example, till 3. Now 4 times 1 into 4 times 1, you will go to 1 2 3 4, then 4 3 2 1. Similarly for 5, you will go till 5. Similarly for n, you will go till n, then reverse till this, you remember, correct? Now one more special number that I saw being asked in CDS, that also I'll tell you. I'll tell you with the question itself. Then there was this perfect number. Perfect number, you remember, sum of all proper divisors. Proper divisor means what? You have to remove that number itself. For example, proper divisors of 6 are 1, 2 and 3, not 6. So sum of proper divisors is equals to the number itself. What are the perfect numbers? 6 is a perfect number. Then 28 is also the next perfect number. Then 496, other becomes much bigger. Correct? Please remember this. I think that some year, like this year, next year, maybe, they will be giving you 28 in some way. Because this is also a perfect number, and people 6 still they can see, 28 people won't be able to see. Then in these only 6 has exact 3 proper divisors. This has already been tested in 2025. Then if ABC, the multiplication of 3 number, is equals to sum of the 3 numbers, now what you have to do, there is 2 3 families that you must remember. One was minus a 0 a, correct? Minus 2 0 2. This is what you normally also take, correct? So this is one family and its rearrangements. Then the non-zero family is 1 2 3, correct? 1 plus 2 plus 3 is 6. Multiplication is also 6. Similarly, minus 1 minus 2 minus 3, this also is another family. Product is minus 6 and sum is also minus 6. Then now consecutive, if you look, if they are asking you consecutive, then there are only 3: 1 2 3, minus 1 minus 2 minus 3, minus 1 0 1. This is fine. Now blank page means let's get to the questions. Yeah, now let's get to this question. This I wanted to talk about all those 3 7 11, I think you remember. Okay, now this is a new pattern that you must know. This is what xy xy xy. Now observe this number carefully. Okay, now see what I am doing. Can you tell me if xy is multiplied by 101, what I will get? Let us find out. Let us write it in small letters. xy multiplied by 101, what do I get? Let's do this. So 101 into xy. Now what I got? Y here 0 y cross. Then x 0 x. So this becomes y x y x. What you got? You got xy xy. Correct? Now see this. So this xy got repeated twice if I multiply it with 101. So this becomes xy xy. Now the same pattern, if I multiply this xy by 10101, now what will I get? What do you think? Now you will actually get xy xy xy. Can you feel this? Now, some people may have a doubt that, sir, why you took 101 here and then you directly went to 10101. Why? Because if you want to take, you can take xy into 1010. This also you take. But ultimately, what is this? 1010 is actually 101 into 10. So whatever answer you got, one more zero you have to add. So this is nothing. Correct? So that is why the next thing that we get to is Sida directly 10101. Similarly, again adding 10, won't be of any use, correct? So again, you will go till 1 more. So can you see? Can you see? Now, if it is multiplied by this number, it is 3 times this, correct? So if it's 1010, so basically you count the number of 1. So 1, 2, 3 ones, correct? So you will get xy 3 times. Here you got 2 ones, so you will get xy 2 times. Next also, can you feel xy if multiplied by 101010 1? Now what you feel? How many x? How many 1? 1, 2, 3, 4. Correct? So how many times xy will be repeated? It will be repeated 4 times. Okay, this is another pattern that you can remember. Now, why I am saying you to remember this? Because this is a cute number, 10101. Okay, now let's find out its factors. This I am putting there. Oh, yeah, let's find it out here. So 10101. Now this is very clearly divisible by 3 itself. 111, correct? So divided by 3 does not matter. Now, how many times? This will go 3 times, 1 will remain. With 11, this will go again 3 times, 2 will remain. With 20, this will go 6 times, 2 will remain. With 21, this will go 7 times. So you got 3, 3, 6, 7. Now, this is actually divisible by 7 also. Let's go 7. So 7 I divide. Now what I got? This goes 4 times, 28. Correct? Now 5 remains. With 56, 8 times, and 1 also remains. 481. Now this is actually divisible by 13 also. So you divide this by 13. Now this goes how many times? 13 3s are 39. Correct? Now what is remain? 9 remain, and then 91. 91 goes 7 times. So last is 37 1. This is why I am telling you this. Otherwise, I won't be introducing new concepts. But this I think you won't be able to figure out if it comes in exam. Okay, and sometimes when they have given that XYZ for the first time in 2023, they gave 2-3 questions on it. So if they give 2 questions, so just learn it for once. Now you know what are the factors. So basically this number that is very cute, it has factors of 3 into 7 into 13 into 30. Remember, not 11. Other than that, all these numbers 3, 7, 13, 37. These are all its factors. Now it is asking you xy is divisible by what number? So what you got? 3, 7, 13, 37, all of these. Correct? So all of these it divides. Please remember this. Then let's come back to our revision part. Now we came to, if you remember, we came to the concept of unit digits, correct? Now we made 3 buckets: 1560, 2378, 49. 4949 was perfect square. It also consists of perfect square 4 and 9, correct? And how many? The cycle is of 2. If even power, then 6, odd power, then 4, even, then 1, odd, then 9. This is fine. This remains the same, always 1560. Then 2378 has a cycle of 4. Remember the value of their powers till 4. If you do this, it becomes easy. Then let's go. Then remember the flow chart for 2378. What you do? Only focus on the last digit, correct? In this number, these are useless. What matters? Oi, 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 oi. Yeah. What matters? Only 2 matters, correct? Then 2 power 82. So what you have to do? Divide the power by 4 and write the remainder in its place. So you divide the power by 4, correct? And write the remainder in its place. Now, if you divide this 82 by 4, what you will get? So if what you will get, 82 by 4, you got 2 as remainder. So you just put 2 above, correct? So 2 power 2, then the answer came out to be 4. Now, the only special case was when the remainder comes out to be 0, then you keep the power as 4 itself. Because if you put power 0, then it will become 1, which is not correct. In 2 power, anything cannot be 1. It has to be even, correct? So if remainder is 0, then you put 4. If you remember this entire algorithm, then another thing was about multiplication and addition when you are talking about last digits. So in multiplication, what you do, you take the last digits, multiply them, get the answer. In addition, again, last digits, take the sum, get the answer. Then some note points: 2 into any number is even, last digit always. It will be 2, 4, 6, 8. 0 is also possible. 0 is also a even number. Then 5 into odd is always 5 as last digit. 5 into even is always 0 as last digit. Correct? This you remember. Blank page means what? Means we get back to questions. Let's go. Now it is asking you, what is the unit digit? What is the digit in the unit place of this? You need to find. Ow. What is the digit in the unit place of the number this? What is the unit digit? Now what you have to do, just the last digits all the time. So 1 power 1 is 1, then multiply 3 power 3. What's the last digit? 3 cube is 27. 5 power 5 is what? Now one beautiful thing I got. See, 5 power 5, any power of 5 always ends with 5 itself. 5 power 1, 5. 5 power 2, 25. 5 power 3, 125. 5 power 4, 625. Always ends with 5. So here the last digit will be 5. Next does not matter. Next does not matter. Why? Understand this. Always remember this. Even power, any number will always be even. Of course, not n is greater than or equal to 1. You are talking about n and n is an integer. Then it always holds. Okay, now even power n is even and odd power n is always odd. Now, one more thing that you are seeing in this question is 5 power n always have 5 as the last digit. Correct? Now, one more thing you remember, 5 into anything odd will always be giving you last digit as 5. What is this? Odd, 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 odd. 7 power 7 also odd. 9 power 9 also odd. So 5 into any odd, what will be the last digit? Last digit will be 5 only. C becomes the answer. Understood? Then next, what is the digit in the unit place of 2 power 100? Now don't get afraid of all these things. What is this? 2 power 100. What does this mean? Ultimately this is some power, no? This is some power. Correct? What you do with powers? What you do with powers? You always divide the power by 4. So you do the same thing. Now you divide the power by 4 and write the remainder here. So 2 power, what should be here? This you tell. Now for this, what I do? I divide 2 power 100 by 4. How many times this will be divided? 2 power 100 means what? I can write this simply as 2 square. Correct? I can write it as 2 square or 4 into 2 power 98. Now 4 and 4 of course cancel out. So what is the remainder here? Here the remainder will be 0. Now if the remainder is 0, what you put there? What you put there? 0? No. What you put? You put 4 there. So 2 power 4 is 16. What is the last digit? 6 is the last digit. C becomes the answer. This is from EPFO 2023. Okay, then let's do more. Yeah, this unit digit again, fairly simple. What you have to do? 7 power 192. 192 means what? Divisible by 4. Correct? 92 divisible by 4. Yes. So 7 power 4 into. Now 3 power 205. Nearest multiple 204. What is the remainder? 1. So this becomes 3 power 1. 7 power 4 is what? 7 7s are 49, 49. 7s are 343, 343, 343 into 7. 7 3 is 21. 1 will be the digit here. So last digit 1 here and last digit 3 here. 1 into 3, 3 becomes the last digit of this multiplication. Understood? Fine. Then before this, let's come back to our revision. Now, next thing was digit interchange. Okay, digit interchange. If you remember, the place value and the face value, correct? 5 into 1000, 8 into 100, 4 into 10, 2 into 1. That we used to write, correct? Now, digit interchange xy if it was 10x plus y, yx if it was 10y plus x. Now what used to happen? So basically if you take their difference, what you used to get, xy minus yx is equals to 9 times x minus y. Remember this, correct? Just have to subtract. Similarly, if you add them, you used to get 11 into x plus y, correct? Now sum of a two digit number and its interchange, that is xy and yx, 25 plus 52, correct? That is this, correct? And their difference is this, that is the difference between a number and its interchange is divisible by 9. The sum of a number and its interchange is divisible by 11, correct? Then for 3 digit, if you remember, adding them was not giving us a lot, so we subtract them rather. So what we got, difference between 3 digit number and its interchanged is 99 into x minus z, that is 99 into first digit minus the last digit. So it is a multiple of 9 as well as 11. Then let's see the questions. Now 7 times a 2-digit positive number is equal to 4 times the number obtained by reversing the order of the digits. Okay. So xy is, let's say, our number. Now 7 times a 2-digit positive number. So 7 times, now this number is actually what? In place value form, this is 10x plus y. This is equal to 4 times the number obtained by reversing the order of digits. So this is equal to 4 times the reversal, that is 10y plus x. Reversal is yx. Okay. Then it is asking you how many such numbers exist. Okay. So let's solve this. Yeah. So this comes out to be 70x plus 7y is equals to 40y plus 4x. Now 70 minus 4x is 66x. 40 minus 7y is 33y. Y came out to be equal to 66 by 33, that is 2x. Oh, similar question came in UPSC also before, but there the answer was none because nothing was given properly. Okay, many pairs were forming, but here it says this is one number and its interchange, correct? So very clearly this is a smaller number, correct? Now let's start looking for its solution. So y is equals to 2x, correct? So y is equals to 2x. Now let's start writing. How you will start writing? You will start with x is equals to 1 because y is double. So you have to make space for it. Now start writing. So this is 1, y is 2. Possible. X is 2, y is 4. Possible? Yes. Double. Then 3, 6, then 4, 8, then 5, 10. Is 10 possible? Is 10 an option? 10 is not a single digit number. Now, here it is not number of pairs, number and its interchange, nothing like this. They made it very clear that this is the smaller number. So, 12, 24, 36, 48. That's why what you can see, all of them are the smaller ones. If you take their interchange, those are much bigger numbers or they lie on this side of 50. So how many numbers? 1, 2, 3, 4. B becomes the answer. Then, is there more? No. First, let's get back to our revision. Now we come to factorization. Factorization, must remember, prime factorization, number of factors, number of trailing zeros. This is what we learned. See, even is what, odd is what, prime is what, one in itself. Composite is has 3 or more factors. Then we learned one more thing, where number is a square of a, now exactly three factors which numbers can have, only when it is a square of a prime number, then only it can have exactly 3 factors. Otherwise it will have more than 3 factors if it is composite, or it will have only 2 if it is prime. That's it. Then prime factorization, we used to write like this you must remember, 2 2 2 3, all that you do. Then you write it in this form. Number of factors was whatever is the power, you add 1 to it and multiply. A plus 1 into B plus 1 into C plus 1 D plus 1 E plus 1. Remember this? Correct. So this is number of factors of n. Then some note points. Number of even factors, what we used to do, just take 1 2 out and then count. Correct. Cause if I take 1 2 out, now everything inside is what, whatever it is does not matter, it will always give me, the multiplication will always give me even number. Correct. Because it will be 2 into something. Fine. So this becomes 2, I take out, forget that 2. Now what remains here? 2 power 3, 3 power 2. How many factors? 3 plus 1 4, then 2 plus 1 3. Correct. Now you multiply both of them. Correct. So what you got? 4 into 3, 4 3s are 12. 12 becomes the answer. This is the number of even factors. Now the other thing was number of odd factors. How you will count? See, either you can find out the total number of factors, then subtract total even factors to get this, or just take power of 2 to be 0. Just forget 2, just hide 2 like this. Now count. If you have to count number of odd factors, you hide this 2 and now count. So now I just hide this 2 or put 2 power 0. Now 3 power 1, 7 power 1. So 1 plus 1 2, 1 plus 1 2, multiplication 4. This is how you count number of odd factors. Then maximum power of a composite number. This has been asked many times. Earlier it used to be asked only in terms of number of trailing zeros. Now in 2025 they also asked you what can be the maximum power of 35 power n. Okay, that I have been teaching for a very long time. Finally it came in 2025. Okay, now so number of trailing zeros is maximum power of 10 in a number. This you understand? Now if prime factorization is given, now they are asking you the power, the maximum power of a composite number. Then what you have to do? Maximum power of a composite number, you have to just take that factor out and then find out the limiting case. For example, if it is asking you power of 6, so you take 6 out. Now whatever remains, for this you calculate number of factors. Here when you are counting number of trailing zeros, correct, what you are doing here, you are just finding out the power of 2 and the power of 5. Whichever is lesser is the limiting case, and that becomes the number of zeros. Fine. This also you remember. Then now blank page means time for questions. Yeah, let's do this. What is the number of factors of this? Fairly easy. What do you think? 24, 8 power 3, 16 power 3. What you will do? First we'll make it beautiful. So 24 power 3 is equivalent to what? From all of them, I can very clearly see 8 power 3 being common. So I take 8 power 3 common. Then what it remains? 3 power 3 minus 2 power 3 minus 1. Correct? Because this was 2 into 8. This was 3 into 8. Now 8 cube, 3 cube is 27 minus 2 cube is 8 and minus 1. So 27 minus 9. 27 minus 9 is 18. So this 2 This 8 cube I can write as 8 is 2 cube. So 3 into 3, 9. 2 power 9 into, here what I got, 27 minus 9, 18. Now again I will write, so 2 power 9 is fine. Then into 18 is what? 18 is what? 2 into 9, correct? So this is into 2 power 1 into 3 square. Now 1 plus 9, so this becomes 2 power 10 into 3 square. This is what you got. It is asking you number of factors. So number of factors will be what? 10 plus 1, 11, correct? Then 2 plus 1, 3. 11 into 3, how many factors? 33 is the total number of factors. A becomes the answer. Fine. Then a 4-digit number n has exactly 15 distinct divisors. What is the total number of distinct divisors of n square? Very good question. Okay, now see how you find this. Think about this. Think about this. A 4-digit number n has exactly 15 distinct divisors. What is the total number of distinct divisors of n square? Now, n has 15 divisors. In other words, n has 15 factors. This you can feel, correct? Now, if n has 15 factors, then understand what happens. What must have happened? What n would have look like? N can look like this. N can look like some prime power, sorry, some prime power 14. This is possible. The number of factors will be what? 14 plus 1, correct? 15. For example, other primes are what? If you take q here, then 0, then r here, then 0, correct? So this becomes what? 14 plus 1, 15. 0 plus 1, 1. 0 plus 1, 1. All multiplied, 1, 1, 1, 1. Ultimately, you got 15 factors. So one possibility is this. This is one possibility, correct? Now, the other possibility can be, see, if you take this possibility, you are not getting any of the options. Now see why. So if n is p power 14, then n square is what? N square is p power 28. How many factors now? 28 plus 1, 28 plus 1, that is 29 factors. Now is it in options? Is it in options? 29? No. So that means this is not the one we are looking for. So this was case 1. We are not finding an option for this. So you do case 2. What is the other way n can look like? Now n can also look like, see, I need to get to 15 divisors. So how can I get to 15? One was 15 into 1. One way to get to 15 was 15 into 1. Is there any other way? Huh? Is there any other way? Yes, there is. 15 you can reach by 3 into 5 also. Correct. So it maybe it looks like P1, make it P1, and the power here is, I need to get 3 here. So power here must be 2, then P2. I need to get 5 here, so power must be 4. Then it will become 2 plus 1, 3, 4 plus 1, 5, 3 into 5, 15. Very nice. Good to go. So n can look like this also. So now I do n square. N square will be what? P1 power 4 into P2 power 8. These are the two things. Now, how many factors? How many factors? 4 plus 1, 5 into 8 plus 1, 9. So what you got? 5 into 9, that is 40. And 45 is that. C becomes the answer. Very good question. You understood how you have to break it down. Once you have this concept in mind, now you can break down anything. Just have the confidence. Okay, then number of zeros, number of consecutive zeros at the end of the sum. Now See, if it has to have 0, understand the last digit is what matters. Last digit has to be 0 first of all. Now you see, this has 10, 20, 30, 40 all being multiplied. So here the q will have last digit as 0. Very nice, I like it. Now, but if you look at p, now people will leave this just by looking at the difficult expression. What is this? 5 power anything always ends with 5. 5 into 5 power anything always ends with 5. 5, 5, 5, 5, 5, 5. What is the last digit? 5 being multiplied many times. For P, the last digit is 5. Now, if you add P and Q, what you will get? 5 plus 0. Correct? So, last digit itself becomes 5. How many consecutive zeros? No zeros, sir. Answer is D. Very beautiful trick question. Just to make you, it was just given to rattle you. Correct? So there won't be any zeros because you get only 5 as the last digit in the first expression, and this is P plus Q, not P into Q. Then okay, this is just a generic question. Let's do this. 0.5 power n plus 0.5 power minus n is always greater than 2 where n is an integer. Now it is asking you this question. If you remember, this is about data sufficiency. Correct? What is this? Is this always greater than 2? What should be the answer? If it is sufficient, this block should be filled by either yes or no. Correct? So you have just box for filling up one word here. If you can definitely fill yes here, fine, sufficient. If you can definitely fill no here, fine, sufficient. I have told you this. Now let's do this. 0.5 power n is what? Isn't 0.5 1 by 2? And 0.5 power minus n. So this is 1 by 2 power minus n. If you know something about minus 1, what is my power minus 1? Isn't this just reciprocal? Huh? Correct. A power minus 1 is what? A power minus 1 is 1 by a. Correct. So here also you can just take reciprocal. So this part will become what? 1 by 2 power n plus 2 power n. I've just taken the reciprocal. Now if I write it like this, so this becomes 2 power n plus 1 by 2 power. This is the expression. Now it is asking you, is it always greater than 2? Now for what values of n will it be greater than 2? What do you think? For what values of n will it be greater than 2? See, if you take any positive value, 1, 3, 5, 6, whatever, this itself will be a very big number. This does not matter, even if it is very small, greater than 2. If you take any negative number, can you feel that this may become small, but suddenly, because you have 2 power minus n also, so this is actually what? This you can also write as 2 power minus n. So if you take minus 2, minus 3, then this becomes plus. So suddenly, still it is bigger. Only possibility that can make this incorrect is if n is equals to 0. Because if n is equals to 0, this is 2 power 0, 1, 2 power 0, 1, 1 plus 1, 2, not greater than 2. It is equal to 2. So n is equals to 0 is the only case that I must avoid. Because if n is equals to 0 is included, then I won't be able to give a sufficient answer, because if you include 0, then this is wrong. If you don't include 0, then this is right. Now, n is an even integer. Is this enough? No, because 0 is also an even integer. Wrong. N is negative. Yeah, if it is negative, it means it is not 0. Is this sufficient? Yes, sir. No problem. So second is sufficient. Answer becomes only one statement alone is sufficient. Only one, that is the second statement. Either alone is sufficient? No. Both together? No. Cannot be answered? No. Answer becomes A. Understood how you are solving this? Ever you have power of something, the limiting case usually lies around n is equals to 0. Always check it. They have given similar question in 24, 25 and 2020 where you had to check for n is equals to 0, or you had to eliminate cases that has n is equals to 0. Then yeah, this is another question. If r power n less than 1 where r is a real number and n is a natural number, again what you will fill here, either yes sir or no, not sir, yes or no. Correct. Now first statement, 0 bigger than 0 is r square, bigger than r square is 1. That means what? That means what? R is between, if r square is between 0 and 1, now if you take any number, for example you take -1, it becomes -1 square is +1. If you take -2 square is +4. Correct. So it will never lie in this region. Only case when it can lie is when r is between -1 to 1. Correct. So from this you got r is equals to between -1 to 1. Now is r power n less than 1? So if you take here, if take power n on all of these, okay, not very correct way, but if you take power n in all of these, what becomes, see, if it is between -1 and 1, now if you take start taking power, so this becomes r power n. What this will be? Between -1 and 1, it will always be point something something, maybe in negative, 0 point something something, correct, maybe in negative, maybe in positive, will always, if you take any power of it, will always be any power will always be less than 1. Correct. So first statement is enough. Then 0, r cube is between 0 and 2. Now is this enough? Again, now 0 r cube and then 2. What do you think about this? Now don't you think r can be, for example, 1 satisfies this, r is equals to 1 is fine. Correct. Something like r is equals to half is also fine. Correct. Now it is saying, is r power n less than 1? In this case it is, in this case it is not. So it is giving you yes and no both. Also if you take for example r is equals to 1.1, now this is what, 11 cube is 1331 or 1.331, again between 0 and 2, but here it becomes greater than 1. So this is also a problem. Even with these two also, you understand that you are getting different possible values of r. So it is not giving you a perfect reply, this statement. So this is not enough. Only one statement alone is sufficient. Understood? Then, yeah, these two questions I have taken. Before that, let's get to the part where we revise. Okay, so this is the algebraic identities. If you remember, now if you remember all the algebraic identities, okay, now please remember them, though not many questions has been asked, but sometimes it may be used, and only if you remember them you will be able to see their use case, because they're not going to ask you the formula directly. Correct. So you must remember them well so as you can see them really. Then, so these are the formulas. Then inequalities, if you remember, what you can do, just like equation, you can do plus, minus, multiply, divide, does not matter. Only exception is multiplying by any negative number is not allowed. If you do that, what you must do, you must reverse the inequality only when you're talking about negative numbers. Fine. Then greater than, less than, equal to, greater than, equal to, all this is fine. Then and or, if you remember, in and what we used to take, x is this also and this also. Correct. So both it must satisfy. Like you have also have to satisfy two roles. Correct. Like the role of a son and role of a husband. Okay. So and or is what? Or is what? Basically you have to do, you have to be this or that. You have to be a doctor or engineer. Correct. So both you don't have to satisfy. So here what we used to take, we used to take intersection. smaller range. Here what you got? Much larger range. Correct? Even if you are this or that or anything, does not matter. So and intersection, range is small, or union, range was large. Then maximize, minimize. If you remember how we used to do, if we had to, for example, minimize x and y, we will minimize x also, y also. Minimum, answer. Maximize x, y, maximum, answer. Now x by y, minimize, how you will do? Minimize the upper part, maximize the lower part. Minimize the, maximize this, maximize the upper, minimize the lower. Correct? Now let's get to question. Now see, this question I have taken for one specific reason. See it and think about it. What do you feel? See, very important. Okay. This is called conditional identities. What you have to do always in these questions, never solve them properly. It will take a lot of time and it is useless then if you have to do it properly. Always think of values, that is values or usually trivial values that can satisfy it. If it satisfies it, then you can use that direct value to find the value of the whatever expression is asked. Now see this. You see this, a square plus this is equals to this is equals to this. Then what is a power 4 plus b power 4 plus c power 4? First thing, how can I find a trivial solution that satisfies this? Can you feel if I take all of them 1, it satisfies? 1 square upon 1 square plus 1 square, 1 by 2, 1 by 2, 1 by 2. Nice only. There is no problem. So only thing that you have to ensure is this should not become undefined, or the expression should also not become undefined because of it. Otherwise everything is fine. It does not. So you put a is equals to b is equals to c is equals to 1. Now what you check, is this expression becoming undefined? No, it is properly defined. Even for this, is this expression becoming undefined? No, this is also working out. So you can take this value. As simple as that. Put 1 1 1. So this becomes what? 1 by 2 is equals to 1 by 2 is equals to 1 by 2. First equation is satisfying. What is the value of this expression? A, B, C all are 1. 1 plus 1 plus 1. Correct? So a power 4 plus b power 4 plus c power 4 is equals to 1 plus 1 plus 1, that is 3. Now, which option has 3? If you put a is equals to b is equals to c is equals to 1, this will give you what? 1 plus, this will give you 1 plus 1 plus 1, 3 into 2. You don't want, you just want 3. Answer becomes a. This will give you 3 into 2, 3 into 3, 4 into 3. All are useless. Answer is a. Very simple. Please don't get bogged down by the expression. They can give this in UPSC also. What you always have to check, find that value. That's it. Now see this. If p plus q plus r is equals to 0, what is the value of this? Now see this. One value that may come to your mind is 0 plus 0 plus 0. But there is a problem. What is the problem? What is the problem? If you take any of them 0, they also come in the denominator. Then it will become division by 0. And any number divided by 0 is not defined. Correct? So that means you cannot take any of them. Any of them cannot be 0. Correct? So if you don't have to take 0, now you think of any other value. Other values are fine. So I take, for example, I take p plus q plus r is equals to 0. I take it 1 minus 2 plus 1 is equals to 0. Anybody has problem with this? Huh? Not even online. What problem can you have? So 1 minus 2 plus 1. Correct? So 2 minus 2, 0. Now, here what values I have taken? I have taken p is equals to 1, q is equals to minus 2, r is equals to 1. These are the 3 values. Now you put this here and let's see what you are getting at. So you put here z power, what it becomes? P square by qr. P is what? P is 1. So this becomes 1 square by qr. minus 2 into 1, that is minus 2. Then z into q square by rp. Q is what? Minus 2. So q square means what? 4. Correct? And by rp is 1 into 1, that is 1. Then z into r square. R square is what? R square is 1. So this becomes 1 upon p into q. So 1 into minus 2 is minus 2. Fine. Fine with everything till here. So this becomes z power minus 1 by 2 into z power 4 into z power minus 1 by 2. Minus 1 by 2 plus minus 1 by 2, or you can minus 1 by 2 plus minus 1 by 2 minus 1. So this becomes z power 4 into z power minus 1. Answer becomes what? Z cube. D is the answer. Remember this, okay? How you solve these questions is using some conditional way, okay? Then, yeah, do this. Let's see what you are up to. This also we have talked about. See, they asked in 2024 that how do you find power of 2? What was the divisibility rule? 16 is what? 2 power 4. So you take how many digits at the last? The last 4 digit. So you need to find 9100 by 16. And that will give you the answer. How many times this will go? I can see it getting divided. Let's divide it the final boss slide. Okay. So now I divide this by 1 time. Okay. See this. 90, 116. How many times this will go? How many times this will go? 5 times is 80. Correct. So you subtract this. This becomes 11. Then 0 you can bring back here. So this becomes what? After this it goes 96. 96 means 6 times. Correct. Now what remains? This becomes 4 and this becomes 10 minus 10 minus 9, that is 14. Now you bring one more 0 here. So this becomes 140. How many times are 140? Table of 16. So this is what you get. 96. 96 plus 16 is 112. Correct. 112 plus 16 is 128 minus 128. Correct. Now what you got? You got 12. So 12 is the remainder. That is understood. Simple. Then, yeah, before this, let's get back to our revision. Now, data sufficiency question we have seen. Okay, that we had seen two types of question, yes or no, value. If you get a unique value, then you say sufficient. If you get non-unique value, then you say not sufficient. Yes, no, we have seen question also. Then, wait, before counting of digits. See, counting of digits, you just see. Okay, not many questions, but let's see this. So basically, pages to digits and digits to pages. If you remember, what were the numbers that you need to remember? This. See, sum of n digits was n. 1 to n natural numbers is n into n plus 1 by 2. This and this formula is fine. Then, yeah, this you have to remember. The two beautiful numbers, 189 and 2889. If they are only talking about single digit pages, then it is 9. If they are talking about 1 to 99, then it used to become 189. Correct. Number of digits used to write those pages. Then from 1 to 999, it became 2889. Remember that. Okay. Then so you look here. This is how we used to remember it. So 9 189 2889 3 8889, like this. Correct. Now let's see remainder also. Remainder is what? D is equals to D into Q plus R. Dividend is equals to divisor into quotient plus remainder. Correct. Now, properties of remainder. This we had seen. Divisor is always greater than remainder. If not, divide further. Smaller by larger, always smaller is the remainder. Then you can distribute it like this remainder, and distribute with respect to addition also and multiplication also. Then special cases, common factors. If there is common factor, what you do? This you must remember. You cancel it out and then you introduced at the last. Correct? So basically cancel them out and introduce at the last. This example, if you remember. Now, one more thing that I told you, that if you get any number like this, eventually any just random multiplication, they usually get to 2. Why? Because for 2, any large number is also very easily defined for remainders. Correct? Odd means 2 will give remainder 1. Even means it will give remainder 0. Understood? Then you can do this BODMAS way, that is, you can distribute it over multiplication, addition, subtraction, all these remainder can be distributed. Then higher powers, n power a by d. What you used to do, if n was greater than d, then you replace n with n by d. But basically, if it was 11 power 32 by 3, so you first remove this 11, difficult to deal with, divided by 3, what is the remainder? 2. So you take 2 here, 2 power 32 by 3. Correct? If it is not so, then you have to treat it as it is. How we used to solve? Take the powers and divide. You are finding for remainder 1. That becomes our core value. After that, we take multiples of it. 4 power 1 is 4, 4 divided by 7, 4 remainder, like this. 4 cube, 64. 64 by 7, remainder is 1. This is what we like. This is what we want in life. This becomes 4 power 3k by 7 gives you remainder 1. So our aim is to find the power for which the remainder is 1. Once we find this, make general cases, split the question based on it. Correct? For example, 4 power 33, now I split it like this only. 4 power 3 into 11. If it was 4 power 34, what I'll do? 4 power 33 into 4 power 1 by 7. Correct? And then move forward. Then 2 power, now this you can remember, 2 power 6k by 7 gives you 1, 3 power 6k by 7 gives you 1. So if it is 2 power something, 3 power something and divided by 7, you just know kahan pe aane wala hai. Otherwise you will have to go till 6. Then yeah, this we have already discussed. Even power even is even, odd power odd is odd, and even plus even even, even odd plus odd even plus odd odd. This and only case how you can get odd is odd into odd. Correct? Then there were remainder cases like this also. Okay, before that, let's do some questions. Yeah, so one question we had done this. Now, let's do this. This is also a good question. A very tricky question. Just think about this. Pause and think. What is this? Triple one power triple two, triple two power triple three, triple three power triple four. Very difficult. Is divided by 5. What is the remainder? Now, for this you must know one thing. How you find remainder with respect to 5? How do you find? If you can get the last digit, you know the remainder with respect to 5. Correct? If the last digit is 1, what is the remainder? 1. If the last digit is 2, 2. Remainder is also 2. 3, then 3. If the last digit is 4, then 4. If the last digit is 5, then what is the remainder? The remainder is 0. If it is 6, then 1 and goes on. You can feel this. If you understand this, then only you can do this question. So this is what? 1 power triple two. What is the last digit? Last digit is 1. Then plus 2 power triple three. What is the last digit? How do you find last digit? 2 power triple three. Triple three you will divide by 4. 32 is a multiple of 4. 1 is the remainder. So you get 2 power 1 here. Then 3 power 444 is completely divisible by 4. So what should I put here? 4 itself abhi to dekha. So this becomes 3 power 4. So this becomes 1. Here the last digit becomes 2. 2 power 1. 3 power 4 is what? 3 3 is 9, 9 3 is 27, 27 3 is 81. What is the last digit? 1 itself. So if you add all the last digits, so 1 plus 2 is 3, 3 plus 1 is 4. So 4 is the last digit. What is the remainder? For 4 you get the remainder. D becomes the answer. Very cute question. Okay, then yeah, see this. So basically, this also you can remember. If n power m is divided by m, where n and m both are prime, then in this case the remainder is equals to n itself. N itself becomes the remainder. Correct? This is the way to do this. Otherwise, there are other ways also using negative remainder and all that, but not needed. So you see here 2 is a prime number, 101 is prime number. This divided by prime, ultimately what will be the remainder? 2 itself. You don't have to worry much even if you forget something. If you just remember that this was prime, prime, something prime, then the answer was, of course, 101 will not even be in the option, correct? And it will not make sense also because you're dividing by 101. You cannot get 101 as remainder. Only possibility 2 answer. Okay, so even if you forget a little, you know how to do it. Then, yeah, so this is actually the question was, if a, b, c, d are natural numbers, then how many possible remainders are there when this expression, when this is divided by 10? Now, this was a very good question. See how. So, basically, these are the numbers. Now, I think this was 2024 CAPF. Now, divided by 10, what are the possible values of remainder? What are the possible values? For 10, what we do? We look at only the last digit. We look at only the last digit, correct? Now you start seeing. So what are the possibilities? 1 power anything will give you A, B, C, D are natural numbers, correct? So that 0 minus all that is gone. So it will 1, 2, 3, 4, something like this. Now, what are the possibility? 1 power anything is 1. So from here you will always get 1 as the last digit. Then next go next. So here, from here you can always get 1. But from 2, what are the possibilities? What can be the last digit? Last digit can be 2, 4, then 4 2s are 8, then 16, that is 6. 4 possibilities, then plus 3. What are the possibilities? 3, then 9, then 27, so 7, and then 1. Correct? Then last 4 power d. What are the possibilities for 4? 4 power 1 is 4, 4 power 2 is 16, that is 6. So these are the possibilities. Now, when divided by 10, what are the possible remainders? Correct? Now, one more thing. If you understand that, you will do it quicker. This is what this is. Let me change the pen. This is odd number, this is even, this is odd, this is even. Even plus even is even. Odd plus odd is also even. So even plus even plus even, ultimately this number will be a even number. If it is even number and divided by 10, what are the possible remainders? So remainders may be 0, 2, 4, 6, 8. Can it be 3? Can it be 1? No, because it has to be even. So 5 possibilities are there. Now, just as yet you cannot mark 5, 6 you can eliminate, because you have to check if these are really forming. So if you check this, you will find that, for example, 1 plus 2 plus, so what you can do, 1 plus 4 you can take. So 1 plus 4, 1 plus 4. Now 1 plus 4 if you take, so this becomes what? 1 plus 4 is 5, correct? Now 5 is there. Now what can you get more? So 5 is there. Now if you take 2 and 3, 2 plus 3 is 5 again. So what is the last digit possible? 0. Then 5 is already there. Now you take 4. Let's say 4 and 9. 4 and 9 is 13, correct? So 13. Then 13 means what? 3 and 5. So you can get 8 also, correct? Then you can take 8 and 7. So this becomes 15. So, but this is not much useful to us, correct? 15 plus 5 again 20. Then 6 plus 1 is 7. So 7 plus 5, this becomes 12. That means 2 is also possible. Then you check for others also. So 2, 0, 8, all these are possible. Now you will find that 6 is also possible, and 4 is also possible. 4 I can tell you, 1 plus 2 plus 7 plus 4. So this becomes 5 plus 9. 9 plus 5 is 14. correct? So 4 becomes the last digit, correct? Similarly, you can get 6 also. So all these are actually possible. Answer becomes C. Now, yeah, this is the last topic that we need to see. Now, this was another type of remainder. What we had to do, we need to find the pattern. So you take something out and then you divide it. As I said, you will get 2 usually here, and then you keep dividing it. You will get some 1, 1, 1, 1 and the answer. Then see this 3 power 32 power 5, 2 power 27. Again, same thing, taking common. Okay. Similarly, one more question we had done was 10 power something something divided by 6. So sometimes you may find a pattern with respect to same remainder being repeated. So that also remember. Then based on identities, this is fine. Sometime if they come a power n minus b power n divisible by a minus b. If it is even, then a plus b and a minus b both. Then this also you remember. Yeah, this was the question. It's an example. Now, very large number, you remember? So they have asked this twice already. So basic core thing was till it is multiple of 6, you just rub it, and whatever remains, that you find remainder for. That was the core thing. Here it was written 99 times. So till 96, till it is a multiple of 6, just remove it. How many lines left? 3. 999 divided by whatever number, find the remainder. Understood? This used to work for 7, 11, 13. Came from those special number, 111, 111. Then same thing is here also. Now this one question was also important, that is x by 61 is 2. Then what is x power 7 divided by 61? So what you have to do, x power 61 into x power 61, all of these will be multiplied. So basically 2 into 2 into 2 into whatever times. So here it is 2 times. So the answer came out to be 4. Remember this, correct? So similarly for x power 6, it will be 2, 2, 2, 2 till 6 times. So 64 by 65, 3 came out to be remainder. Yeah, this was the question that I was talking about. You can find a pattern also. So sometimes look for pattern if you're not finding anything. All remainders were actually 4. Then we come to HCF and LCM. Now, this one method I have also taught you, that you know this method, of course, finding out the HCF. You do till you get common in all of them. Otherwise, you cannot take in HCF. Now, another method that I taught you was you can take the difference between them, and when the smallest number starts dividing the other differences, that itself becomes the HCF. Remember this? I'll show you one question that is based on this only. Okay, then this was LCM. Now, some note points. HCF into LCM was product of two numbers. Only holds for two numbers. Okay, only holds always for two numbers. Whenever HCF of numbers is given, say k, how you take the numbers? You take the numbers as kx and ky. Always remember this. This is very useful. Okay, then where one property x, y have no common factor. So x, y are co-primes. Then yeah, this was a question where we had taken this 22x, 22y and then solved it. Then find the largest number which when divides this leave remainder 27. So your which when divides means you're finding out that small number which is dividing the other. So mainly it is a HCF question. So what you have to do, just subtract this number 62 minus 27 minus 27. You get these three number and find their HCF. Remember this. Then there was remainder using LCM. So type 1 was what? Basically smallest such number where you take LCM, which these are the divisors, they are leaving remainder R. Each of them leaving the same remainder R. So what you do? You find the LCM of all the divisors plus some small remainder, the same remainder that you are getting, that is R you add. If you are asked a series, then it was N into L, that is the LCM of all the divisors plus R. You can always multiply only with the LCM, nothing else. Then this was type 1. Type 2 was what? These were the divisors. They left remainder, different divisor, but the difference was same. And this difference we used to take k. Then the least number used to become LCM of these minus k. So series was what? Now again you can multiply only with the LCM. So n into L minus k. Remember this? Fine. Then yeah, how do you identify this in word problems? So HCF options are always less than the number which when divides distribution into groups. This is HCF. LCM is options are greater than the numbers which when divided by simultaneously together, then it is LCM. Now numbers are always greater than their HCF, always less than their LCM. One more thing, that LCM will always be divisible by the HCF, of course. Correct? Then yeah, these fraction ones. Remember this A by B, C by D. What? How you used to remember? Because this is HCF, so this will be small. So you take LCM in the denominator, HCF in the numerator. Here what you do? HCF in denominator, LCM in numerator. Remember this? Okay. Then yeah, then it was telling you what kind of questions you have to leave. For this I have made another video also that you must have seen. Number of solution, number of possible values, many variables like this, trial and error. These questions you should avoid. Similarly, data sufficiency also should avoid in the first go. Now let's get to the questions of HCF and LCM and then we'll be done. Okay, so very good question again. If the HCF of P and Q, P is greater than Q, is G, then which of the following statements is are correct? That is why we wrote as a note. What we wrote as a note? If HCF of any two numbers is given, for example, HCF of P comma Q is given as G. Now, what I told you, you always write P and Q in terms of G then. So P is equals to Gx, correct, and Q is equals to G pi. Correct? Now, the first statement. HCF of P and P plus Q is G. Let's check. Let's check. P is equals to what? Gx. And P plus Q is equals to what? Gx plus Gy. Now, if you take this G common, then this becomes G into X plus Y. This is G plus G into X. Now, is G the highest divisor between them? Or is there any other possibility? There is no possibility. Why? Because in this X, Y are co-prime numbers. So here if you try to divide it by X, so this is divisible, but Y won't be divisible by X at any cost. This is how you define it. So what is the biggest divisor of both of these numbers? G only. Similarly, this also same thing, Gx into, and here Gx minus Y, again the largest divisor of both of them, G again. So both of these statements are absolutely correct. Then let's see this. The HCF and LCF of two numbers P and Q is 44 and 2460. Okay. Now what I will use, if P, when P is divided by 55, okay, then the quotient is 4 and remainder is 0. Oh, they have given the value of P only. P is equals to, see, quotient, dividend is equals to quotient into divisor. So 55 into 4 plus remainder is what? 0. 55 into 4 is what? 50 into 4 is 200. 200 plus 20, 220. So they have given the value of P also. Correct. They have given the HCF also. HCF is 44. They have given you the LCM also. 4620. Now they are asking you the other number. What is the formula? Now we won't even solve. See this. Be smart. Okay. This is the product of number, that is P and Q. Correct? Now HCF is what? HCF is 44. What is LCM? LCM is 4620. Now see this. P is what? 220. Q I don't know. Fine. Now if I'm solving for Q, what is the value of Q? Can I cancel 0 and 0? I can cancel. Now what will be the last digit here? 0 I have removed. Now I write it again. 44 into 462. This is 22 into Q. What is the last digit here? 4 2s are 8 is the last digit. Correct? Here also I want 8 as the last digit. What option is giving me 8 as the last digit? So this into 2. What is the last digit? 0. Reject. This into 2. 8 is the last digit. Yes, possible. This into 2. 0. Again, rejected. Then this into 2, what is 0? Again rejected. 924 becomes the answer. You need not solve it. Never solve questions like these. They are mostly based on last digits. Okay, then last two. If n is the greatest number, that will divide 600, 631, 724, leaving the same remainder. What is the value of n? It will leave the same remainder when dividing all these three. This is what? This is a smaller number dividing a bigger number. Essentially, what is being asked? Essentially, what is being asked? What can be the greatest value of n? Whatever can be the greatest value here. So here I start finding out. See, the difference between them is the maximum close you can get. Correct? You cannot go beyond it. Correct? You cannot go closer. So now start finding out what is the difference. 31. Then 631 and 724. What is the difference? 724 minus 631. So this becomes 312 minus 3 is 9. This is gone. So this becomes 93. Then let's take 724 and 600 also. So this becomes 124. What do you think? Is 31 dividing the other two numbers? Is 31 dividing the other two numbers? Yes, sir. It is dividing the other two numbers, that is 93 and 124. Correct? So that means 31 is the closest you can get to. D becomes the answer. Understood? Fine. Then next. Last question is this. There are 4 bulbs A, B, C, D in a room. A glows for 2 minutes and then goes off for 1 minute. Okay. So this is A. It glows for 2 minutes and then for 1 minute it goes off. Then, so after 3rd minute it is on again. Correct? Or at the 3rd minute it is off. Can you feel this? Then, so and it goes on. So A is, if consider A, this is the 1st minute, it is on. 2nd minute, this is on. 3rd minute, it is off. So when it is off? At the 3rd minute. Then 4th minute, it is on. 5th minute, I am closing my eyes. On means I have to open it. So 4th minute it is on. 5th minute it is on. 6th minute it is off again. So then it is off at 6. Then it is off at 9. Then 12. Then 15. Then 18. Goes on like this. Now, next is similarly B glows for 3 minutes and goes off for 1 minute. Can you feel this now? B glows for 3 minutes, then goes off for 1 minute. So which minute it is gone? 4th minute. Then again 3 minutes it will go. Next one at 8th minute. Then 12th minute. Then 16th. Then 20th. Goes on. Then C. C is on for 4 minutes, gone for 1 minute. Okay. So basically what it becomes? C is on for 4 minutes and gone for 1 minute. So this becomes 5 and 10 and 15 and 20 and so on. Now D. D is what? 5 minutes on, 1 minute off. This is 6 and 12 and 18 and now it is asking you if a man enters a room and then stays there for 1 hour, then leaves. What is the maximum number of time he can see the room completely dark? That means all lights are off. That means what? Isn't this the LCM of all these 4 numbers? What is this? These are multiples. You're finding that least multiple that is divisible by all of them. Correct? You're finding out the common among them. So 3, 4, 5, 6. What is the LCM? 3, 4, 5, 6. What is LCM? Goes 3 times 1, 4, 5, 2. Then with 2, 1 time, 2 time, 5 time, 1 time. Correct? Now 2, 5 will remain as it is. So 3 2s are 6, 6 2s are 12, 12 5s are 60. So in 60 minutes, it will go off completely. Now, it is not saying, it is saying what is the maximum number what is the maximum number of times he may face complete darkness in an hour. So you consider that case where he does face darkness, not the integrate or the limiting case. Correct? So in 60 minutes, maybe that minute is just coming about. He enters, after 5 minutes, it goes off. Correct? That is possible. Now, can he see it again? Because the next time it will come after 60 minutes, he'll be gone from that room. So how many times maximum? D, that is 1 time. Okay, so this is it for your number system revision questions, everything. That's it. Thank you.